First section of notes today is titled Adding, Subtracting, Rational Expressions. The first problem is 5 over AB plus 8 over A. If you remember to add two fractions together, you must first have the same denominator. In this case, both denominators have an A, but the first fraction has an extra B. So what we can do on that is multiply the second fraction by B in the denominator. But what you do to the denominator, you also have to do to the numerator. So multiply by a B on top and bottom. Once they have the same denominators, you can add the fractions together. 5 plus 8b would stay the same. Both denominators are ab, so your denominator would be ab. Second question is 3x over 4y squared minus y over 6x. Again, you have to have common denominators before you can add or subtract fractions. In this case, if we have 4 and 6, you can get a common denominator between 4 and 6, which would be 12. To make this 4a12, you can multiply by 3. Again, in the denominator and numerator. To make the 6 a 12, you can multiply by 2 in the numerator and denominator. The variables have to be the same also. There's a y squared in the first denominator, which means we have to have a y squared in the second denominator. And again, you multiply numerator and denominator. There's an extra x in the second fraction. So again, we have to have x over here. And the first fraction in the numerator and denominator. If you rewrite this out, we have 3 times 3, which would be 9. X times x would be x squared. The denominator would be 3 times 4, which is 12. And you have y squared x. And we have the minus sign from before. 2 is the only coefficient for the second fraction. Y times y squared would be y to the third. 2 times 6 would be 12. X, y squared. And if you look at the denominators, both of them have 12, both have a y squared, both have an x, so they have common denominators. Final answer, just combine the two fractions. 9x squared minus 2y to the third would stay the same. And 12y squared x. Normally you'll have x before the y, so we can rewrite it as 12xy squared. You can check and see if you can reduce fractions, but there's no x to factor out of the second term. 9, 2, and 12 can't be reduced, so it just stays the same. The last section of notes today is called More Complex, Rational Expressions. The first problem is m over m squared minus 4 plus 2 over 3m plus 6. And again, before we can add fractions, we have to have the same or common denominators. For this question, we can actually factor each of these denominators. If you factor the first one, m would stay the same in the numerator. Difference of squares would be m minus 2 and m plus 2. And the second fraction, you can take out the greatest common factor, which would be 3, and you're left with m plus 2. Now if you look at the two fractions, they both have m plus 2 in common. The first fraction has an extra m minus 2, which means we have to multiply this fraction by m minus 2 in the denominator and also the numerator. The second fraction has an extra 3. So again, we'll have to multiply the first fraction by 3 in the numerator and denominator. If you rewrite these fractions, we have 3m in the numerator, then 3m minus 2, m plus 2, and then plus our second fraction, which is 2m minus 2. And our denominator would be 3m plus 2, m minus 2. And if you look at each fraction, both denominators have 3's. Each denominator has an m minus 2 and m plus 2, so they both have common denominators. In this second fraction, you can actually distribute this 2 out. That way we'll be able to add 3m to what's left over. 2 times m would be 2m. 2 times a negative 2 would be minus 4. So for our answer, we have 3m plus 2m, which would be 5m, minus 4 is left over. And our denominator would be 3, m minus 2, and m plus 2. You could rewrite this m minus 2, m plus 2 as our original denominator m squared minus 4, but it's best to leave it in factored form. Our second question is 7 over y minus 8 minus 6 over 8 minus y. In this question, both denominators look similar, but they're off by a negative sign. We have y and negative y. We have negative 8 and positive 8. If the denominators are off by a negative, what you can do is multiply by negative 1 in the numerator and denominator of either fraction, but we'll do it to the second fraction for this one. First fraction stays the same. The negative out here, or minus sign, would stay the same. 6 times a negative 1 would be negative 6. And if you distribute this negative to the denominator, you have negative 1 times 8, which would be negative 8. Negative y times a positive y. Negative y times a negative 1 would be positive y. And if you look at our denominators now, we have positive y and positive y, minus 8 and minus 8. It's actually the same denominator. The second one's just changed around. Since they're the same denominator, you can combine the numerators. 7 minus a negative 6 would actually be plus 6, 13. And the denominator is y minus 8. This denominator again is the same thing, y minus 8. And your final answer, 13 over y minus 8. And we have one more question for this section. Last question for this section is x plus x over 3 divided by x minus x over 6. In this question, you have a fraction inside of a fraction, So we'll have to simplify that out so we just have one fraction for our answer. If we look at just the numerator of this fraction, we can combine these. You can make the x a fraction by making it x over 1. And if we get common denominators, then we combine this to one fraction. For example, this one down here we can multiply by 3 on top and bottom. Rewriting the fraction, x times 3 would be 3x. 1 times 3 would be 3. And then plus x over 3. Bringing the fraction line over. Now we can do the same steps to the denominator of the original fraction. X minus x over 6. We can make x over 1 and then get common denominators, multiplying by 6. That would be 6x over 6 minus x over 6. Combining these fractions, again we have common denominators on these top two fractions. So 3x plus x would be 4x over 3. And then again the fraction line in the middle, 6x over 6 minus 1x over 6. 6x minus 1x would be 5x over 6. Now we have a fraction divided by a fraction. If we rewrite the problem, 4x divided by 3, instead of a fraction line, you can put a division sign, 5x over 6. And now it looks similar to a problem that we did in a previous section, where you can multiply by the reciprocal. 4x over 3 would stay the same. Division changes to multiplication. And again, do the reciprocal of the second fraction by flipping it over. And then you can multiply straight across to get your answer. You can also cross cancel. 6 divided by 3 would be 2. The x's here would cancel. And you'll be left with 4 times 2, which would be 8, and 5 in the denominator. So your final answer would be 8 over 5.